Hi everyone, my name is Janine Ko, aka Janine The Tutor. We understand that now is a very difficult time for each one of you, whether you're in middle school, high school, or university because of the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt to the circumstance quickly, and that's why we want to help you students stay on top of your studies. So for today's class, I will be covering the popular questions that we've been receiving on homework help from OneClass for the math section. Right, so before I begin, I just wanted to make sure that you can hear me coming through and also you can see my screen. So you should be seeing two panels. So here's the question. Yeah, so this is the first question. So it says, what value of x is in the solution set of 2x minus 3, which is greater than 11 minus 5x? So anytime we have an inequality, so say for example, from this question, they're asking us what's the value of x, right? So we would have to write 2x, and this is minus 3. This is greater than 11 minus 5x, right? And because I'm seeing a negative 5x over here, I can actually move this to the opposite side of the equation such that it would become positive 5x, right? So if that happens, we would get 7x. So this would become 2 plus 5x, this becomes 7x. And as a result, because we still have that greater than symbol, so we're going to keep that. However, we have the negative 3, so that negative 3 moves to the opposite side of the equation, such that it becomes 14, right? And we divide both sides with 7. That's why you get x, which is greater than 2. Okay, great. So now from here, as you can see, anytime you have an inequality, right, and because we're looking at the solution set, so that means we have to have a number line, right? So you're going to be graphing essentially such that you have 2, and we know that this is 0 over here, right, because it's less than 2. And as you can see, because it's saying it's greater than 2, right, that means our inequality, right, it's not including 2, right, because it doesn't say greater than or equal to 2, right? That's why this is going to be a whole over here, and this is going all the way after 2, right? Because it says greater than 2, that means it's any number, right, after 2. And 2 is not included. That's why this is the solution set, which is x greater than 2. So I know in this figure they didn't really show if 2 was included or not, but I think it's really important for us to make it a habit to include or do not include the x value. Hopefully that makes sense. Okay, great. So now let's take a look at what they wrote. It says given the inequality, right? And then they're getting 7x greater than 14. That's right. That's right. So it's x greater than 2. All those values of x which are greater than 2 are solutions to the inequality 2x minus 3 greater than 11 minus 5x. Yeah, it's perfect. So we have nothing to correct. Okay, so solution is correct. Okay, great. So moving on to the next question. It says which function, and let me just close this because it's very distracting. Okay, so which function represents a vertical stretch of an exponential function? So anytime you have, say for example, okay, so apparently the question is in here. Yeah, I just realized the question is in here. So when they say option A, so just forget about all of our options, right? But because they're laying out their solution, right, in here, if we have f of x, which is equal to 3 times 1 over 2x, anytime you have an exponential function, you're going to have a factor, right? So your factor is going to be 3, right, over here. So this is, it just so happened that we have a vertical stretch of 3, and then you have this 1 over 2, which is essentially your base, right? Because if you have an exponential function, so say for example you have a, right? Typically on textbooks they would write it as a, which is any value, right? And in this case, because it's in a fraction, right, it's still considered an exponential function because it's any base raised to the power of x. That makes it an exponential function. And as you can see, we have a vertical stretch over here, which is 3, right? So yeah, apparently there isn't any option here. So as we know that an exponential function can be stretch or shrink both horizontally and vertically. To stretch an exponential function, vertically simply multiply it by a real number greater than 1. Okay, so when they're trying to express this statement, right? So anytime you have a vertical stretch, the value that you multiply, which is considered a factor, this needs to be greater than 1, right? And what that means is if you have a fraction, that wouldn't be considered as a stretch, right? So that's what they're trying to say here. Okay, yeah, so this is right. Okay, but I would say explanation is right, however, options weren't provided. Okay, great. So I'm just gonna say solution is correct since their explanation was right. Okay. So moving on to this question, so we have which equation can be simplified to find the inverse of y is equal to 5x squared plus 10. So anytime you're trying to find an inverse of a function, right? And again, we don't have any options here, so just omit option A, right? This should be gone. But anyways, the goal here is to find the inverse of y, which is equal to 5x squared plus 10, right? And what we're doing, if we're trying to find the inverse, is if we have y, which is equal to 5x squared plus 10, and maybe let's see what they got, so just so we know. Okay, great. So they're trying to just switch the variables. Okay, so anytime you're trying to find the inverse of a function, right, you have to keep in mind that if this was f of x, you would have to switch this into y, right? And why do you need to do that? Well, anytime you're finding the inverse, this y becomes an x. So you actually interchange your variables. If you have a y, it becomes an x, and if you have an x, it becomes a y. So you would have 5y squared, and this is plus 10, right? And I know that they're only specifying x is equal to 5y squared plus 10, which is part of the step of finding the inverse, but maybe if we can find what the inverse is, that would be great. So if we have x is equal to 5y squared plus 10, that means once we've done step 1, which is to interchange, right? So this is step 1. So we interchange any of our y into an x and any of our x into a y. The next step would be to isolate y, right? Just like we're solving for y, right? Any type of function, you would have y on one side of the equation. So that's the next step. So we would have x, and this is minus 10, and this is equal to 5y squared, right? So this 10 over here moves to the opposite side of the equation, and in that way, this becomes a negative number, right? And because there is a 5 here, we need to isolate just y, so we divide both sides with 5, and we take the square root, right? Okay. My pen is okay, great. So we take the square root. There we go. So we simply have y left because 5 divided by 5, right? And we know that if you have a square root, that means it's an exponent of 1/2. You multiply that to 2, right? That would give you just y. And as you can see, this is basically x minus 10, and this is over 5, right? Or you can actually cut this into 2, right? So you would have y is equal to square root of x, and this is over 5. Then you have, actually, I think it's better to keep it this way because if you have the minus sign, you would just have like 2 inside. Yeah, I think it's just better to keep it this way, but that's the inverse of a function. Of that function, rather. Okay. You can't really simplify the square root of x minus 10 over 5, so this is actually simplified, so you don't really have to do extra work. So yeah, you interchange your variables and then you solve for y. So that's how we find the inverse. And then let's say you're interested in trying to figure out whether there is really an inverse, right? So all you have to do is, but I'm not going to do that right now because that's not the whole point of this class, but I just wanted to let you know that anytime you're trying to find the inverse of a function, a way to double check that is to actually compose your functions. So if you have y is equal to 5x squared plus 10, right? So you know that this is your function, for example, so this is f of x, and let's say this was your inverse, right? Then all you have to do is you compose your function. So say for example, you have f of x, and this would become f of f inverse of x. So you're going to compose your inverse and simultaneously you're going to compose your function. So this is f of inverse, then you have f of x inside. Okay, let me move that down. Okay, so we said one of your function is 5x squared plus 10. And then the next step would be to compose your inverse. So that's how we solve for this. Okay, so as you can see, your final answer when you compose that needs to be simply x. So it's an identity function, and that's how you know the two of them are inverses of one another. Okay, great. So that's just an extra, I guess, concept, but that doesn't really answer the question. So for this part, because they're only asking for the equation that can be simplified as a way to find the inverse, then this is fine. So I would say explanation is correct. However, we don't have any of the options. Okay, so solution is correct. Okay, so this question, it says the product of a plus 3 and negative 2a squared plus 15a plus 6 is negative 2a cubed plus xa squared plus 51a plus 18, and now we want to find the value of x. So, as you can see, they're specifying that we have a product, right? So we're going to have essentially an equation where the left-hand side or the right-hand side is up to you, really. But just for simplicity, I'm making the product into, sorry, I'm turning the product, which is a plus 3 and negative 2a squared plus 15a plus 6, and I'm putting that or placing that to the left-hand side. So this is negative 2a squared, and this is plus 15a plus 6. And this is going to be equal to, as you can see, negative 2a, and I don't think we're going to fit. So let me move this. Okay, so we have a plus 3, and this is going to be multiplied to negative 2a squared plus 15a, and this is going to be plus 6, and this is equal to this, which is negative 2a cubed plus xa squared, and this is plus 51a, and this is plus 18. Okay, great. So now that we have that, we have to expand the whole thing and try to simplify as much as we can, and later on we're going to see what happens to our xa squared. So again, we're just applying the FOIL method, so you multiply a times negative 2a squared. So that becomes negative 2a cubed, right? The next one would be to multiply a times 15a, so that would be plus 15a squared. Next up, we have 6 times a, which is going to be positive 6a, right? And then your inner term, so outer term and then your inner term. So you have negative 6a, and this is squared. Moving on to 15 times 3, so that's going to be 45, and this is positive 45a. And when you multiply 3 times 6, that's going to be 18, right? And everything is going to be equal to negative 2a cubed plus xa squared, and this is plus 51a plus 18. And maybe I can move this. Yeah, I just wanted to have everything in just one line. I know it's a bit smaller, but I think it's easier to cancel things out. Okay, so great, we have that. Okay, so as you can see, you have an 18 here and an 18 here. So if you move this 18 to the other side or the other way around, you're going to cancel that 18 out ultimately. So that's why I'm canceling this out right now, because it's 0. And then what I'm trying to do now is I'm grouping my like terms. So again, you have negative 2a cubed here. This cancels out with the negative 2a cubed, because if you move this to the opposite side or this to the opposite side, you get a positive 2a cubed, and that just becomes 0, right? Now, if you look at 51a, so that's right here. What else? You have 45 and 45a, and you have 6a, right? So maybe we can add 45 and 6. So 45 plus 6 is going to be 51a. So these two actually adds up to 51a, right? Maybe we can write that. And then we have this 15 minus 6, so that becomes 9a squared, right? So this is a like term, or these two rather are like terms. Then you have 51a, which is equal to xa squared, and this is 51a. So as you can see, this 51a can also cancel out and result to 0 because they're both positive. And moving this to the opposite side would just turn it into negative 51a, so that just cancels out, right? Because it's 0. And then you get to this point where you have a squared over here, so that means x must be 9. So that's why you know that the value of x is 9. And let's take a look at what they did. Okay, so they expanded. You have negative 2a cubed, right? So that's on the left-hand side, plus 15a squared, plus 6a minus 6a squared, plus 45a plus 18. This is absolutely right. And then on the right-hand side was basically base from the given. So that's negative 2a cubed plus xa squared plus 51a plus 18. Okay, great. So that's done. And then they simplified this, right? As you can see, we canceled out the negative 2a cubed, 9a squared remained. We had 51a as well, right? And then we had the 18 and the 18 on this side. And ultimately, the 51a is going to cancel out, right? So yeah, so their value is x is equal to 9. Okay, so we don't have anything to correct because this is perfect. So perfect solution and answer. Okay, solution is correct. Great. So now let's move on to logarithms. So here we need to solve log of x minus 16 is equal to 4. Okay, so what I'm doing right now is I have this x over here, and this is negative 116, and this is equal to 4. Okay, so there is a difference when your base is x as opposed to x minus 16, right? And they didn't really specify that in that question. So, and the reason why I'm saying that is because if you have, like, let's say log of x, right? Sorry, not the base, but this over here, because we know that the base is 10, as you can see, which they haven't really written down, right? Because we don't typically write the base of 10. But what I'm trying to say here is there is a difference between saying your log is x as opposed to log is x minus 116. Does that make sense? Because that creates your translation. So, and we're just going to assume that this is going to be just log of x, right? And you have that negative 116 over there. And the way that you're going to solve for this is if you have, let's say negative 116 is here, how do you cancel out the negative 116 and rid of that? So that means you would have to add positive 116, right? Because if you have positive 116, then that just gives you 0. So if you have plus 116 over here, right, this becomes 0, and you're ultimately left with log of x, right? And this is going to be equal to, so 116, and this is plus 4, so this is equal to 120. Does that make sense? So you have log, right? Base 10, you have x is equal to 120. And because you need to solve for x, right? We know that for log, the inverse of logarithms are going to be exponential functions, right? Or exponential function, the inverse of that is logarithms. So you need to remember this by now. We have this template equation, which is y is equal to log of ax. So this a is your base, right? In this case, this would be 10 for this equation, and you have an x over here. Now, because it's an inverse, right, of your exponential function, we would have to say ay is actually equal to x. So all we have to do here is apply this ay is equal to x. We know that our a is 10, right? This is log of base 10. Your y value is 120 coming from here. So this is going to be 120, and then simply this is just your x. So that's why x needs to be equal to 10 raised to the power of 120. And I don't think you need to express what 10 raised to the power of 120 is, because that's just going to be a huge number. I think you can just keep it as an exponent. Okay, yeah, so this is the exact same thing that we did. Again, just keep in mind that there is a difference between saying it's x minus 116 or it's just simply log of your x. So okay, solution is correct. Great. So let's move on to this question. I thought this was an interesting question because apparently you're just looking at the strokes for the pattern. So if you notice, right, I guess I can illustrate that. I think it's easier if we capitalize our letter. So the whole point of this question is about patterning. So if you have 1 and this is I, right? And then you have 2, which is L, right? If you notice, right, if you write I this way, that's just 1 stroke. If you have L this way, this is 2 strokes, right? 1 vertically and 1 horizontally. And then for the third one, you have F. Let's see. 2L, and then you have 3F, yeah. So the third one is F, so 1, 2, 3, right? That's 3 strokes. And then for the fourth one, you've probably guessed it, it would be E because it's 1, 2, 3, 4. 4 strokes. So the next letter after 4 should be E. Yeah, so they're just looking at the, okay, design. I would say it's the stroke of the letters, so perfect solution and answer. So yeah, 1 is for I, then you have 2 lines for L, then you have 3 lines for F, then 4 for E. Perfect. Okay, so we need to find the volume of a 3D trapezoid. Okay, so let's see. Let's try to look at what they have here. Okay, so this is a trapezoid that they will be looking at. And it says a trapezoid is a plane figure with one pair of parallel sides. That's right. So the parallel sides would be the legs, right? So this is this leg and this leg, right? So we know that just by looking at the trapezoid, your base is a trapezoid, right? And this is in fact a trapezoid prism or trapezoidal prism, depending on which one you prefer. And then it says, yeah, so we have a trapezium base. And let's see, the volume of a 3D trapezoid is obtained by multiplying the area of a trapezium base with the height of the trapezium. Multiplying the area with the height. That's true. And the reason for that is because anytime you're dealing with volume, you would have to take the area of your base, right? It's very similar to a cylinder if you think about it, because in a cylinder, when you're trying to multiply, when you're trying to find the volume of a cylinder, right? You can compare this with a cylinder. You're basically taking the area, right? And then you're multiplying that to the height. That's why it's pi r squared h. Because the area is going to be part of the volume, right? So you have to multiply that to the volume. And even for like a rectangular prism, right? If you think about it, it's length times width. So that's the area of your base. And then you multiply that to the height, right? So same thing here. So as you can see, they're taking the area of the trapezium base. So this is 1 over 2 times c plus b. So when they're referring to c plus b, it's basically the two legs, right? Because we take the average, right? So this and this divided by 2, then you multiply that to the height. So that's the area of your base. And then all you have to do is you multiply that to your actual height, which is coming from the prism, not the height of your trapezoid. But on top of that, just remember that for the area of your trapezoid, there is a height which is coming from the trapezoid. So this is the trapezoid's height. And then for the volume, you need to multiply that to the height based from the rectangle, which is forming the prism. So there is a difference between the two h's. It's not just because they're both h, it means it's the same height. No, it's different. Okay, great. I have nothing to correct. It's a perfect explanation. So okay, so we're now going to look at reflections. So it says, what set of reflections would carry triangle ABC onto itself, right? And you're going to see 4 options here, right? So let me try to explain this figure over here. Okay, so I know they wrote a bunch of reflection, reflecting a point, and so on and so forth, right? But the whole point here is what they're trying to get at is basically when you reflect this, right, based from the x-axis or reflect on your x-axis or y-axis, right, you're going to be moving this image that way. And that's what they have here. If we reflect it about the y-axis, right, so reflection about the y-axis, so where's your y-axis? It would be here. Therefore, you're going to see that your image or triangle ABC is now in quadrant 2, right? And then subsequently, if you reflect that, so coming from quadrant 2, right, reflect that about your x-axis. So now picture this in your head. You have this figure, right? Triangle ABC is now in quadrant 2, and then you're trying to reflect that on your x-axis. So this is where your x-axis is. Therefore, this figure is now going to move to quadrant 3, right? So that's what they have. And then once it's in quadrant 3, right, you're going to reflect this again, right? So quadrant 3, you reflect on your y-axis, and when you reflect on your y-axis, it's now going to be in quadrant 4, right, which is here. And then you go back basically to quadrant 1 because you have another reflection in your x-axis. So that's what they're trying to say here. So this is going to be y-axis, right, to be placed in quadrant 2, x-axis to be placed in quadrant 3, and then you have another y-axis because you want to move from quadrant 3 to quadrant 4, and then you have another reflection on your x-axis to move from quadrant 4 to quadrant 1. Okay. Yeah, it has nothing to do with the points really. You want to keep the points the same just because you want to have the same points for A, B, and C. So there's no point trying to move the points. Because otherwise, if you move one of the points, this needs to be moved or translated the same way you translated all your other points. Otherwise, you're not going to have the same area for your triangle. So yeah, perfect solution and answer. Solution is correct. Okay, great. So we're now going to move on to domain, range, and asymptotes, right? Anytime you have an exponential function, you're always going to have an asymptote. I'm just putting that out there. And the domain of any exponential function is always going to be all real numbers, which in terms of interval notation is going to be from negative infinity to positive infinity. Or you can say x is all real numbers, right? That's the domain of all exponential functions. However, for the range, it's going to depend on your translation. So if you were to just look at h of x, which is equal to 2 raised to the power of x plus 4, if this positive 4 did not exist, right, if we said this was just h of x, which is equal to 2 raised to the power of x, we're going to say that the range is going to be from y and it's greater than 0, right? That means it's 0 to positive infinity. And the reason for that is because you have a horizontal asymptote at 0 if this 4 didn't exist. So if you have h of x, right, this is equal to 2 raised to the power of x. So you need to understand your parent function first before you actually deal with your transform function. So as you can see, so this is your exponential function, and you're going to have a horizontal asymptote at y is equal to 0. That's why when you're referring to your range, that means your range is going to be from 0, right? Y greater than 0, and y is not included, right? Therefore, it's going to be 0, comma, positive infinity. However, because you have 2 raised to the power of x and you have that plus 4, so that plus 4 actually translates your function up, right, by 4 units. So that's why for h of x, and this is equal to 2, and raised to the power of x, and this is plus 4. So now you're going to start at 4, right? So you actually do have a horizontal asymptote at y is equal to 4, right? So maybe I can extend our y-axis. So yeah, this is now your function, right? So it's 2 raised to the power of x plus 4. So you're seeing a horizontal asymptote at y is equal to 4, right? Initially, we had that at 0. So in that case, your range changes from 4, from 0 to 4, right? That's why, let me just write that down. So range is equal to 4, right? In terms of interval notation, this would be written as 4 is not included. That's why we have a round bracket, and this is to positive infinity, or comma positive infinity. And we know that the domain is always going to be x, all real numbers, right? Or you can say in terms of interval notation, it's negative infinity to positive infinity, right? So this is just an or. And then if you want to state your range in terms of the y value, right? That means you would have y, and this is greater than 4. And what else? Asymptote, right? So your asymptote is going to be at y is equal to 4. So let's see what they wrote. Okay, so I don't think we need to do, or we need to take the log here, but let's see what they're trying to do. Yeah, personally, I wouldn't take the log because I think it's just time consuming. I think you need to understand your parent function and then you look at your transform function, and that way you observe what's happening to your transformation. I think that's the best way to go, especially when you're writing your test, because you have no time to graph this and you don't even have a graphing calculator, right? So you actually need to know what your parent function looks like. So yeah, I would just focus on your exponential function because you're not solving for x, right? There's no point to be taking log and let's see what they're trying to do. And then have log y minus 4 over log 2. I think if you have x, which is equal to this, it just becomes harder to graph because first of all, how can you graph log y minus 4 divided by log 2 on top of your head? So I think just know the parent function and yeah, just stick to simplicity, right? Don't even complicate things. Just focus on h of x, which is equal to 2 raised to the power of x, and that's it. Okay, great. So, but yeah, the way they've drawn their function is actually right. However, I wouldn't go to that length to be looking for log and plotting your graph. So I would just say focus on the parent function. Okay, but let's see what they wrote. So in terms of domain, as x tends to positive infinity, then y tends to positive infinity, and as yes, y is equal to 4 is the only horizontal asymptote. Domain, they didn't really say what the domain is. Okay, so the range they're saying is all real numbers which are greater than 4. I wouldn't say all real numbers. I would just say the range of g of x is greater than 4. That's what I would say. Don't include all real numbers, because the way if you say all real numbers, that's generalizing that 4 is also included. So try to avoid that if you're trying to say y is greater than 4. So keep it this way. You're not supposed to say all real numbers. Okay, domain was not mentioned, so that's my comment. Domain is x is, let me just maybe type that here. X is all real numbers, or negative infinity. Okay, let me just quickly have the infinity sign. Okay, there we go. So negative infinity, comma, positive infinity. So that's there. And then your range, yeah, I wanted to say y is greater than 4, or you have 4, comma, and just make sure, because y is not including 4, you need to have a round bracket over here. Because there is a difference between having a round bracket and also a square bracket. So just keep that in mind, and horizontal asymptote is correct. So okay, great. Solution is correct because part of it was correct. So okay, great. So it says here which equation can be used to solve for C, and we have a right triangle, right? I know they didn't really specify that, but the only way for you to solve for this question is you're going to use SOHCAHTOA, right? So maybe we can have that here. Okay, so I'm just gonna copy whatever is in here, all the information. So we have M and O, then we have 40 degrees over here, and we know that this is B, then you have C, then you have 6, right? Okay, so now think about it. If you have SOHCAHTOA on top of your head, right, that means if you're looking at 40 degrees, right, you wouldn't really pick sine because you're referring to the opposite side and also your hypotenuse. Well, if you have B and C unknown, right? I mean, as unknowns, right? You can't really solve for anything, right? So that means you want to keep your unknown just one, right? Just one value. So in that case, you're going to be use cosine, right? Because if you have cosine, your unknown is only going to be C, right? Because if you have 40 degrees, right, this is going to be adjacent. So your adjacent side is 6, right? And your hypotenuse is simply going to be C. And how do I know C is my hypotenuse, or the length of your hypotenuse? Because that's opposite of your right angle. So you would have 6 over C, as opposed to sine earlier, right, which we had B and C, and that's just not gonna solve for C, right? You can't solve for C if you have two missing components, right? And then for tangent, right? For tangent, we know that this is opposite and adjacent. So opposite would be B, right? So yeah, you can solve for tangent, right? It's just gonna give you B, and then you have to use 6 ultimately, right? And then you get B, and then you have to do another step to solve for C, right? So you can use tangent, right, to solve for B, and then you can apply sine to solve for C. So it's a two-way step, but why would you waste your time, right? So in that case, you would have to solve for C, right, using cosine. This is the quickest way to do that. And you have cosine 40 degrees, and this is equal to 6. So what I'm doing is I'm just cross multiplying so I can isolate C, right? So once you have C over here, you're going to divide both sides with cosine 40. So that's why you're going to end up with simply C on one side. So C is equal to 6 over cosine 40 degrees. So that's your value for C. So what did they say? So A would be the answer. 6 cosine 40 degrees. So I'm not saying that sine and tangent you cannot use them. I'm saying that the quickest way to solve this question, right? If you want efficiency, you need to use cosine, right? But obviously you can use tangent and then use sine and then you get to the same answer for C. So, okay, option A, that's what we said. There should be an H in hypotenuse and MN is opposite to angle. Okay, so they're trying to explain you have your perpendicularity between, yeah, MN and NO. That makes it, and that creates a right angle. That's what they're trying to say. And okay, so the reason why this doesn't work, it's not sine that we're using, right, first of all. So B and D rather are eliminated. And also, if you look at C, we're not multiplying 6 times cosine 40. So that makes it incorrect. So it has to be A because it's 6 divided by cosine 40. So yeah, perfect solution and answer. I have nothing to correct, so. Okay, so how many pints are in a quart? Yeah, so for these types of questions, you just have to really know your conversion by heart, and then all you have to do is look at the ratio. So this should be given on a test. I don't think teachers would actually ask you to memorize these conversions because there's just a lot. So they might give you, like, let's say, okay, so 1 gallon is 4 quarts, and then maybe you can solve how many cups using unit analysis or dimensional analysis. But in terms of trying to memorize all of this, I don't think they're gonna do that because that's not the whole point of doing this, right? The skill here is to be able to convert from one unit to another. So because they're saying that you have 1 quart and that's 2 pints, that's just going to be 2, right? And then they're trying to give you an example, right, which you can apply, right? So if they're asking you how many pints are there in 2 quarts, then you know that if you have 1 quart, right, that's 2 pints, then all you have to do is you multiply 2, right, to get that ratio. So 1 times 2, so this becomes 4 pints, right? That's why it's 4. Okay, so I don't think this was a hard question at all. So this is the perfect explanation. So nothing to correct. So solution is correct. Okay, great. Next question, it says, what are the possible turning points for the continuous function? Anytime you're trying to look at turning points, and the fact that they actually written this function down in terms of your vertex form, you know that it's a parabola, right? So your turning point, right? If you think about a parabola, right, you only have one turning point. So in that case, your turning point would be your vertex, right? So you're going to have a turning point at 1, right? Because we know that this is x minus 1, right? That gives you x minus 1, which is equal to 0, right? So we know that this is going to be x is equal to 1, right? All you have to do is move your -1 to the opposite side of the equation, so you get x is equal to 1. And how do you find your y value? Well, in order for you to find your y value, you would just have to plug in 1 on your equation, right? So this is just going to be 1 minus 1 squared, and this is minus 2. So your y value is going to be -2, right? So from here, and this is 0, that's why. And just remember that anytime you have the vertex form, right, that means your h comma k, right, which is your vertex. So if you recall, we use the coordinates h comma k to represent the vertex. That means you're just taking this as 1 and your k value is going to be -2, which is just coming from this. So that's why it's 1 comma -2. So that's your vertex. And that's your turning point, because we know that a parabola has just one turning point. However, I think they did a different step here. So they actually differentiated, but I don't think that's even necessary because you're just being asked what the turning points are, right? And we know that right off the bat it's a parabola. So, but if you're doing the calculus way, then all you have to do is expand this function, right? Once you've expanded the function, you take the derivative. And why do you take the derivative? Specifically the first derivative, because you want to identify your critical points, right? And what does your critical points tell you? If it's equal to 0, right, there is a possibility, right, you observe your, okay, let's just do that. So great, so we find the first derivative. So if you have your function f of x, which is equal to x minus 1, this is squared minus 2. When you expand this, and why do I need to expand this? Because it's easier to take the derivative. So you have x squared minus 2x, and this is plus 1, right? A minus b squared, right? It's a squared minus 2ab plus b squared. That's the formula. And then you have minus 2. So as a result, you see that this is x squared, this is minus 2x, and this is minus 1. So when you take the first derivative, you're going to have 2x, and this is minus 2. Okay, so we look at the critical points, right? So what are the critical points? That means it's either the first derivative is equal to 0 or the first derivative does not exist, right? Because we know that this never happens, right? In terms of does not exist. So if it does not exist, this never happens. And then if you look at the first derivative when it's equal to 0, then we can say that you have 2x minus 2, and that's equal to 0. You have 2x, which is equal to 2, dividing both sides with 2. We know that x is going to be 1 when the first derivative is 0. So from there, okay, what the first derivative tells you is basically your local minimum and your local maximum, right? So we know that this is x is equal to 1, right? Then all you have to do is you go back to your f of x, right? You just need to plug 1 into your equation, right? Similarly, you're just going to get -2, right? 1 minus 1 squared, and this is minus 2, right? You're just going to get -2, which is the exact same thing as your vertex just by looking at it, right? So your first derivative tells you your local extremas. So that's why we're solving for the first derivative. Okay, that's what they did. X is equal to 1 is a critical point. You have your increasing and decreasing. Yeah, you identify the intervals of increasing or decreasing if it's applicable, and then they're saying that since -infinity and 1, okay, so when they're trying to do that, right, if they're trying to identify the intervals of increase or decrease, right, okay, so there's two ways to identify the intervals of increase or decrease. It's either you do the first derivative test, right? So when you have the first derivative test, all you do is you have 1 over here, and then you take any point that is less than 1, right? You cannot use 1 because that makes the function, or sorry, the first derivative, right? The reason why you cannot use 1 is because that makes the first derivative equal to 0. That's why you can't use 1. So you're going to observe what happens to the values that are before 1 and after 1. So let's say you plug in 0.5, right? So when you plug in 0.5 to your first derivative, right, you're going to see what happens. So sorry, you take 0.5, you plug that into your function. So where's your function? Your function was here, right? So you take any value that is before 1 and after 1. So let's pick 0.5, plug that into your function. So 0.5 minus 1 squared, and this is minus 2, right? So you're going to get a negative value, right? And then as you can see, if you look at anything that is after 1, let's say 5, right? That's after 1. This is going to be positive. So because you have a change in sign, right, which is negative to positive, right? That means, and that's what they said, the derivative of the function has a negative sign, and then you have f of x is decreasing on negative infinity to 1. So what that means is you have a local minimum, right? So at 1, over here, you have a local minimum. And that's where the function is, right? And specifically, we said it was at negative 2. So we need to shift this parabola down. So negative 2. So there's a local min over here. And how do I know it's a local min? Because it changes from negative to positive, right? Anytime you have a local extrema, your signs change. So that's the first derivative test. Or you can actually simply just graph this 2x minus 2, right? We're going to see that it looks something like this. And you have negative and positive, right, in here. So this is where your 1 is at. And it's a linear function. That's why it's sloping up because it's a positive slope, right? So yeah, apply the first derivative test, or you just graph 2x minus 2. Great. So yeah, so it's increasing from 1 to infinity, as they've mentioned. Okay, maybe we can say an alternative explanation, because I don't think it's worth, I mean, if you don't need to apply the calculus part over here, I don't think it's necessary to go in depth in terms of looking for the derivative and then trying to see where the intervals of increase or decrease is, right? Because we know that it's a parabola, so you can just say because it's a parabola, you're only going to have one vertex, and that vertex would represent a turning point. So that's what I'm trying to say. Since it's a parabola, we know that a parabola can only have one turning point, and that's which is actually can only have one turning point, which is its vertex. Okay, solution is correct. Great. Amazing. Okay, so next question, we need to look at the following options, and it says which would prove that triangle ABC is similar to triangle XYZ. Okay, so first of all, when two triangles are similar, that means their sides or their lengths of the sides are proportional, right? It doesn't mean that they're equal to one another or congruent. So, and they're trying to say that option A is the correct answer. So if you look at AB, right, we can actually say that AB over XY. So anytime you're trying to set up a ratio for similar triangles, you need to make sure that the ratio that you're creating, right, when you have your numerator and your denominator, right, this AB needs to correspond to the smaller triangle, right? So if you have XY, that's coming from the bigger triangle. So when you set up your fraction, your numerator, because you started from the smaller triangle, which is ABC, yeah, it's ABC. So in that case, when you're trying to set up the other fraction, your numerator should have the dimension for your smaller triangle as well, right? So when you say you have AB over XY, that's going to be equal to AC over XZ, right? Does that make sense? And then when you have that equal to BC, right, you need to have your numerator coming from your smaller triangle, and that's going to be over your larger triangle, the dimension of your larger triangle, and that needs to be YZ, as you can see over here. And the reason why B is wrong, because if you're taking AB and you're saying that this is over YZ, right, they're not really coming from the same side. They're not corresponding to the same side. That's why this was That's why B is incorrect, right? You can't use that. You need to have the corresponding side. And then if you take a look at C, you have AB and then you have XY. Okay, so this is right. And then you have AC, but they wrote YZ, right? So it's not supposed to be YZ because when you have AC, that should correspond to XZ, right? And when you have BC, that should correspond to YZ and not XZ. Okay, so for part D, you have AB corresponding to YZ. Okay, as you can see, they're not corresponding sides. That's why B to D, they're incorrect. So we're trying to say that this is a side, 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 similar triangle. So I have nothing to correct, so it's a perfect solution and answer. Okay, so I guess we'll just leave off from this question for today's class. Okay, so it says, what is the square root of 164 in simplified radical form? Okay, so anytime you're trying to find the square root of something, if you remember what I said from previous classes, you have 164, you take what you call your least common multiple, right? So when you have your least common multiple, what that means is you're going to think of prime numbers, right? I know prime numbers come back way from middle school, but we need to pick the numbers that typically only has a factor of itself or one, so that's prime numbers, because we want to make sure that when you're trying to have that square root, as you can see over here, when you have prime numbers, it's just easier for you to group the numbers together as opposed to having 10 and 8, right? Because if we can simplify, for example, 10 and 8 in terms of the base of 2, right? That just makes it easier for us to group numbers. That's the whole point of trying to find factors that are prime numbers, right? It's just for the sake of grouping. So if you have 164, we know that we can divide this with 2 because it's an even number, right? And how do I know it's an even number? Because it ends in 4. And 4 is an even number. So 164 divided by 2, that gives us 82. And again, 82 is an even number, so we can still use 2. So 82 is divisible by 2, so 82 divided by 2, we get 41. And finally, we know that 41 is a prime number. You can't really think of any factors aside from 41 and 1, right? So that makes it a prime number. Therefore, because we're taking the square root, right? Yeah, so here it says square root of 164. So remember what I said, you're supposed to group your factors as a pair because you're taking the square root. And what happens here is you take the positive and negative value of that square root and you are able to take out that 2 and then you have square root of 41. And why that occurs is because if you have the positive and negative value of the square root of 2 times 41, you're going to see that this is actually equal to the square root of 4. And what happens here is if you have the square root of 4, right, that becomes just 2, right? And that's the whole point of grouping. I think it's just easier that way. So you would have square root of 4, right? Then you multiply this to the square root of 41. So that's what happens. So when you split that up, that's still going to be 2, right? And make sure anytime you're taking the square root of something, you need to have that positive or negative value. Okay, so this, they're saying 2 square root of 41. Yeah, so perfect solution and answer. I have nothing to correct, so. Solution is correct. Okay, great. So, yeah, I just wanted to thank you guys for coming in and attending my class. I know right now is probably so difficult just because everyone is like moving online, and I guess the last thing that you want to have is a class online, but I really hope that you are able to grasp the concepts we learned today, and I hope this empowers you to do even better in your studies. Once again, yeah, this is Janine the Tutor, right? And I'll see you on my next class. Bye, guys.